React Native perform well on multiple platforms and create a rich user experience. It's no wonder it's the choice of leading companies.
For your final project, you will create a beautiful, functional mobile application for your portfolio, complete with interactivity to showcase during your job search.
You'll also be ready to collaborate with other developers as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in a smaller team, not to worry.
We've also got you covered when it comes to the basics of user experience.
You learn how to research a user's needs,
Create wireframes using popular industry tools like Figma,
and design interactivity.
In the final course, you will prepare for the coding interview.
You'll practice your interview skills, refine your resume,
And tackle some common coding challenges that typically form part of technical job interviews.
Who knows where you will end up?
Whatever the future of Connection looks like, you'll be part of its creation. Let's get started. Many people consider a career in software development, but are maybe not quite aware of exactly what goes on in different development environments. This course serves as an introduction to a particular environment known as mobile development, which encompasses the area of cross-platform development. This development area is best described as building software applications that can run on multiple mobile operating systems. Place that definition in a real-world context. Let's examine a typical mobile development project. As an example, let's assume our project is to create an app. Just to mention that when you come across the term app, it could refer to an app on your phone or to a web app that runs on a website or by some other online method. For ease of reference, here the sample project is portrayed as a phone app. It's our first project example, so let's pick an app that is not too complex. Perhaps a productivity tracker. And what does the productivity tracker aim to do? This app enables a business user to track items such as tasks, dates, times, and appointments. To help the user plan their schedule, it will include task lists with priority ratings, such as low, medium, and high. It will sync with other planning apps, such as calendars or project planners. Tasks can be upgraded to calendar slots so that they become items on the user's schedule. Various screen views are required, including weekly, monthly, and yearly overviews. Finally, there is the requirement to filter the tasks and appointments by several criteria, but especially criteria relating back to our task priority ratings. Filtering within specific time periods is also a necessity. And did I mention this app will be released to both iOS and Android phones? So if you are creating this app, you face some challenges. Let's list some of them. Don't worry if you don't fully understand all of the terms right now. After all, that's part of the reason you are taking this course. Some challenges in the productivity app project are cross-platform compatibility, user interface design, programming the code, which includes testing and debugging, and connecting to and synchronizing with third-party apps and tools. That is a short example of a not very complex app, but it does illustrate the sorts of tasks and challenges faced by cross-platform developers. During the course, you'll be introduced to these and the many other tasks that are the responsibilities of a mobile developer. You will start by learning how the web works. You will discover the fundamental components of the internet, such as networks, web servers, clients, and web hosting. You'll also explore web browsers, websites, and web pages. Next, you will learn about different platforms, how they differ, and how developers use cross-platform mobile development frameworks to create products that run on multiple platforms. Then you'll get the opportunity to gain the fundamental skills required to become a web developer using HTML and CSS, and discover the vast array of developer tools available to you. Finally, you'll explore React and React Native, their relationship to JavaScript, and how you can use them to facilitate cross-platform mobile development. Of course, you're not expected to build an app right away. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a mobile developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in the course, you must commit to a regular, disciplined approach to your learning regime. You need to be serious about your study, and if possible, map out a study schedule with dates and times that you can devote to attending the course. It's an online, self-paced course, but it does help to think of your study in terms of regular attendance at a learning institute. In summary, this course provides you with a complete introduction to mobile development and is part of a program of courses that lead you toward a career in software development. Technology continues to expand into a wide range of devices. As you go about your daily routine, you've possibly interacted with technology on many devices, from mobiles to wearables or even refrigerators. Partly because of the increase in these different devices, the demand for web and mobile developers is high and continues to grow. That growth makes cross-platform programming skills invaluable to any developer. Cross-platform developers make software applications that are compatible with multiple operating systems. And there's currently a shortage of specialized application developers. A specialized developer focuses on a particular domain with great in-depth knowledge. That type of demand means that upskilling yourself in a cross-platform application development could be a smart move. The skills you gain with a course like this can lead to many opportunities for employment. Both newcomers and seasoned developers can find job opportunities in the current market. In this video, you'll learn more about the roles associated with a skilled cross-platform application developer and the typical skills and tasks associated with such jobs. What kinds of things does a cross-platform developer do? Well, job descriptions can vary greatly depending on the position advertised. Each company and even each project may require a different approach. Some of the common tasks and responsibilities shared by cross-platform developers include writing code, always a prime requirement of a developer, and it's especially important to have clean, readable, and error-free code when the aim is to create apps compatible with several operating systems. Dealing with bugs, another time-consuming issue that typically occurs, involves finding and fixing bugs and attending to performance issues. Development of new app features and new UI or user interfaces for the app. Often this can entail upgrading existing code. And application monitoring to identify problems. You might do this by observing app performance or analyzing data. Developers are also involved in building clean and smooth animations and transitions. These are design techniques that help to provide an excellent UX or user experience. Other common cross-platform tasks include integrating third-party technologies like application program interfaces or APIs to connect the app with other technologies or code, writing tests, and releasing applications and updates to the Apple and Google stores. That's a brief overview of some common tasks and responsibilities you're likely to find in a cross-platform developer role. Many of those tasks involve coding. So what kinds of programming languages do cross-platform developers need? Well, the language required often depends on the project or the company, but language choice is primarily guided by the framework. A framework is a platform that provides the foundation and tools to develop software applications. It's sometimes compared to a template that you modify by adding your own code. The most important language for you to know is the one that the framework is based on. Just 3 are mentioned here, but many other frameworks are available. For instance, the React Native framework uses JavaScript. Flutter uses Google's programming language, Dart, and Xamarin is built using the C# programming language. Apart from the language associated with the framework, a development language may be related to particular platforms. For instance, Android developers use languages such as Java and Kotlin, while iOS developers use Objective-C and Swift. Then, many development tasks will involve using HTML, CSS, and JavaScript. These are used to build websites or applications. While not considered to be actual programming languages, learning these can expand your choice of job roles and projects. Okay, so I think I've covered that it's great if you know a language and its associated framework. For example, if you learn JavaScript, you're then ready to explore cross-platform development with React Native. And I've also emphasised that it's a bonus if you have proficiency in other languages. Furthermore, I'd consider it wise for cross-platform developers to at least be aware of some related skills and concepts. That includes being knowledgeable about standard web development, the browser, and third-party integrations like REST APIs, which help you to interact with RESTful web services, such as getting weather or geolocation data. Apart from the many coding skills, developers often work as part of a team, which can include other developers, project managers, QA professionals, and designers. Knowing how to use tools like Slack for chat, Zoom for video calls, and Jira for support tickets makes it easier for you to integrate and stay connected to the team. Your role may involve helping to plan projects and participating in the project progression by attending team meetings. In addition, you'll find that almost all developers spend some time researching their projects, watching emerging trends, and keeping up to date with the language and platform changes. Okay, let's say that you've mastered your cross-platform development skills. Now, where in the job market do you find work? Because cross-platform development skills are in demand, there are many roles available for web and mobile developers. Let's explore the job options. Cross-platform development is popular with small companies and startups who understand how apps can aid their growth, and is equally useful to large companies. For instance, they may want to build apps that help them gain a slight competitive advantage or foster engagement with their user base. Contracting development agencies often use cross-platform development as it helps them to quickly use existing talent and offer more services. There's a high demand for developers, but perhaps you are not attracted by any of the job offers. Well, having cross-platform development skills means that you can work as a freelance web app developer or start your own development company. From specialists to general software engineers, cross-platform development is used widely and is in very high demand. As a result, it's an invaluable skill set to have. You should now have a better understanding of a cross-platform developer's role, their responsibilities, and the skills they need.
About 84% of the world owns a smartphone, which means that whatever app you build is going to have tremendous impact. I'm Sarah Pack, and I am a software engineer at Meta based in Menlo Park, California. My story of being a mobile developer actually started with me as an economics major in my undergrad. While I was in my economics courses, I was hearing about all these hackathons, free pizzas, free swag. I decided to try one out, and it was the first time I ever picked up any mobile development. And I created a very almost embarrassingly simple app. I did not win, but I learned so much while creating this app, and I just loved the ability to see what I code come out to real life and see people use it. A typical day at Meta looks like me starting out with communications. So I look through a bunch of emails or chats, posts, whatever I might have missed. And while I do that, I pull the latest code and set up my development environment so that I can be prepared to code when that time comes. Typically, we have meetings scattered throughout the day, and that's to connect with cross-functional partners like product manager, design, other engineers to push projects forward. When I'm not in meetings, then I get to focus on the technical pieces, like designing the technical architecture or, of course, coding. My favorite part of the workday is when I have a chunk of time to really dive deep into coding and, in particular, UI development, because I love just seeing what I code come out on the surface of a phone or some device and seeing the design and the buttons, the views, the images showing up. One of the most challenging things as a mobile developer is that you have to be aware of app size. And this means that any code that you build, any function that you add, needs to be as concise as possible. You have to be aware that the device has limited memory. And so whatever you build and every line you add adds to that memory. And you have to be very careful and cautious about it. But the great thing is, this does help you to become a stronger engineer because you're really making sure that every line you add is going to work well and efficiently. Some technical skills that I use on a daily basis is first the technical language, as you might imagine. Currently, I use a mixture of native templates, blocks, and iOS native code to build our features. I would say another technical skill I use every day is data analyses because these are important for understanding how a feature works, whether people are finding a benefit out of it or not, based on whether they're using the feature or not. And this really helps to inform the engineers what to fix and what to improve. Communication, that one is key because we at Meta really work as a team and we have a lot of different functions. So, coming in from an engineer background where we might speak with a lot of technical lingo, we have to make sure that we use layman terms to convey why building a certain thing may take so much time or why it's fast to build another way, and be able to convey that in a very concise and understandable way for product managers or designers or content designers who don't have any technical background. And this really helps to drive the projects forward. There is no shortage of things to build at Meta. So, being able to prioritize what will be the best experience for users and also be efficient in terms of building for the engineering technical side is really important to balance out and prioritize so that we really hone in on the best features. The way we work with iOS and Android developers is a lot of collaboration. Within each platform, all the engineers work together, divvy up tasks to build for that particular platform. But across the two platforms, we also collaborate a lot because the way we implement on one, such as Android, we implement very similarly on the other, such as iOS. So we share a lot of our implementations across the board. And because both also share the server work, we are able to collaborate a lot and share our knowledge. The way that a mobile developer's role is different from a UX or UI designer is that the UX or UI designer creates the mocks and the draft form of what we should build on a screen, what it should look like. It's like a drawing. And then the engineer then takes that and actually builds it and makes it work on an actual device. So you can kind of think of an analogy of like an architect who would draft out the drawings of the building, and then a constructor then goes in and actually builds it. And so the engineer is the constructor, and the UX UI designer is the architect. I have noticed that good engineers are able to build out the UI fine, but excellent engineers really understand what's going on under the hood so that they can efficiently debug an issue. And if you have that solid foundation, you'll be a very strong mobile developer because you'll understand what's happening. Technology does move fast, and with mobile development, you really do interface with people. People's behavior affects what we build. But we've also found that technology influences people's behavior. It's really interesting to be at the forefront of seeing the evolution of how these two influence each other and hopefully and ideally ensuring that technology does its best to serve people. Being a mobile developer is a very specialized skill set, and it is high in demand in the market. Here at Meta, we are always in need of more mobile engineers. So it'll be a great skill set to have. It'll really truly make you a well-rounded engineer compared to other engineering tracks because you're not only building algorithms or code, but you're also trying to interface with the user, which means you have to understand the product and you also have to understand the data. It is really special to be able to know that what I build impacts so many people and that billions of people use it. That's what gets me up every day at work because I know that the work I put in really helps people to have a better experience within whatever technology they're using within Meta. And I wish you the very best on your exciting journey to become a mobile developer.
Hello and welcome. Did you ever find yourself searching for something online? How long did it take to get a response from your search? You search for something and you get a response back in no time. That's really something, isn't it? But did you ever think about how it all happens? In this video, I will guide you through the basics of how the internet works. Let's start at the beginning. You open your favorite app on your device and you're instantly connected to the world. This is all made possible because two devices connect and communicate via a wired or wireless connection, forming something called a network. You can connect multiple devices to this network, but this becomes very complicated very quickly as each device needs to connect to every other device to communicate effectively. This problem is solved by something called a network switch that connects multiple devices and allows them to communicate with each other. The network switch can connect to other network switches, and now two networks can connect. These network switches then connect to more network switches until you have something called an interconnected network. This interconnected network has another name that you might be familiar with. It's called the Internet. When we use websites or video streaming services on the Internet, these are provided by computers called servers. Our devices are called clients. This is known as the client-server model. The Internet connects the entire world. Have you ever had a video call with someone on another continent? That video data traveled through large undersea cables connecting the world's networks, and these cables can transfer huge volumes of data per second. There are a lot more technical details that go into making the Internet possible, but this is the main idea. Hopefully, this gave you the big picture of how the Internet works. You may have heard the terms web pages and websites, but what's the difference? A web page is a document that displays images, text, videos, and other content in the web browser. A website is a collection of web pages that link together. You've likely visited many websites this week. In fact, you're watching a video on one right now. Let's explore an example where you visit your favorite encyclopedia website. When you arrive at the homepage, it contains many links to different articles. Clicking on one of those links brings you to a new web page article, and that article links to even more articles on other web pages. If all these web pages have a similar address in the web browser's address bar, it can be safe to assume that they belong to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, when you visit your favorite search engine and search for a phrase, the search results are a list of links to other websites. Did you know that as I'm talking to you, thousands of websites are being launched to the Internet? Every day, hundreds of thousands of websites are launched. To put things into perspective, the Great Pyramid of Giza has 2.3 million blocks of stone. So think about it. In 1 week, there are as many new web pages as stones in the Great Pyramid. With current internet speeds, it would take 3 million years to download all the web pages on the Internet. And all of these billions of varied web pages rely on the same core technologies. Most people interact with websites in some form daily, but few know how a web page actually works. I mean, what's it made up of? And just how does that web page get from the web server to what you see on your screen or device? Well, let's explore that now. In its most basic form, a web page is just a text document. You can open and edit with any text editor, but developers usually use more sophisticated tools for working with web pages. If you want to work with a web page, you need to know about 3 technologies and understand how they interact. They are HTML, CSS, and JavaScript. HTML structures the content you see, CSS controls the colors and style, and JavaScript is responsible for the user interaction. As a web developer, you will work with these technologies every day and understand how they work together. I always like to imagine it like this. Think of a shop. HTML is the actual building, the structure. CSS is the interior decoration and landscaping outside, and JavaScript is just like the business, the services offered, and the people coming in and out. Let me give you a brief overview of each of these technologies now. HTML stands for Hypertext Markup Language. It works by using something called markup tags. These tags describe the content that is displayed in the browser window. This content can be things like headings, paragraphs, images, and even multimedia elements such as audio and video. The way HTML describes the content is known as markup. CSS is short for cascading style sheets and adds visual enhancements like colors and layout to the web page. This is commonly known as styling. It works by enhancing the HTML elements and telling them how to display. Have you ever noticed a friend change their color or style of their hair? Well, your friend's hair is like the HTML, and the color and style is CSS. The last technology is JavaScript, which is a programming language built into the browser. JavaScript provides web developers with tools for interactivity, data processing, control, and action. Have you ever tried to log into a website only to be told that the information you provided was incorrect? Or browsed your favorite video streaming site and seen content update in real time? Well, that's JavaScript in action. JavaScript is the powerhouse of a web page. It has the ability to manipulate the content that you see on the screen as you interact with it. In fact, without JavaScript, websites would be kind of boring and very limited in terms of what you can do. Okay, you now know about the essential technologies a web page contains, but how exactly does this code get translated to display the content that you see on your screen? When a copy of that web page is sent from the web server to your browser, each line of code is processed in sequential order from first to last. As each line is interpreted, the browser creates the building blocks, which is the visual representation you see on the screen. This creation process is known as page rendering. The response from the web server must be a complete web page in order to fulfill the request to show the page in the browser. You will learn more about page rendering from the additional reading at the end of this lesson. And there you have it. You now have joined the exclusive group of developers who know how a web page works. You learned about the technologies that make up a web page and how they interact with each other. You also learned that the page is rendered by the web browser to display what the end user sees on the screen. In the time since you started watching this video, another few thousand websites launched. Every one of them is another example of modern web developers building and adding to the ever-growing internet. Are you ready to become one of them? You use a web browser every day on your devices, and you probably have one open right now watching this video. But do you really know how they work? In this video, you will learn what a web browser is and how it receives and displays content. Let's get started. A web browser, or browser for short, is a software application that you use to browse the World Wide Web. It works by sending a request to a web server and then receives a response containing the content that is to be displayed on the screen of your device. Once the browser is open on your device, there is the address bar where you input the address of the website that you want to visit. The address is commonly known as the Uniform Resource Locator, or URL for short. The URL contains the protocol, or the HTTP, the domain name, usually the name of the website, and the file path, or the path to the page that is displayed. When you make a request using this URL, the browser and server communicate using a protocol known as the Hypertext Transfer Protocol, or HTTP. Once the web browser receives the content, it displays it on the screen of your device. This exchange of information is made possible by something known as the request-response cycle. Now, let me demonstrate this using an example many of us are familiar with, searching the web. First, you open a web browser, which is a software application. Next, you type the name of your favorite search engine. The name you type contains something called a domain name. Then, when you press enter, the web browser sends a request across a network and connects to another computer on the internet called a web server. The web server is a special type of computer that allows other computers to make requests for data. The web server responds by sending a web page back to the browser. Once the browser receives all the response information, the search engine web page is made visible. The web page is a coded document that is rendered by the browser and then presented visually to you, the end user. Now that the search engine web page is loaded in the browser, you interact with that page to search for what you want to find. For example, type restaurants near me in the search bar and press the search button. Once again, the browser prepares and sends a request to the same search engine web server. This time, the request contains the added instructions to search for the phrase restaurants near me. The search engine web server processes the request by taking the keyword and using it to find the requested data. This data is stored in something called a database, which is connected to the web server. The web server then picks up that data and sends it back to the browser. When the web browser receives the full response from the web server, it again renders a visible web page with links to some restaurants, a map showing nearby locations, and more related information such as reviews, lists, and even reservations. Success, and all made possible by computers having a conversation. You have now gained an insight into how the request-response cycle works. And this web request cycle is very similar for a number of other activities we do online, be it chatting with friends, watching our favourite movie, or sharing files with our work colleagues. That is just a brief summary of how the internet works. The next time you search for something online, think of all the steps and data that gets exchanged to complete your request.
How much time do you think you spend each day using mobile apps? Studies show that people spend on average a fourth of their lives using apps. Mobile apps have become an important part of people's lives. Tasks such as booking accommodation, ordering food, or staying connected are now easier than ever. In this video, you explore how the mobile industry evolved to become an integral part of modern life. It all started when the first handheld cellular phone was invented in 1973 by Martin Cooper. Another major event in the 1970s was the development of cellular networks that connected mobile phones to the internet. The public, however, only got access to mobile phones in the 80s. But in the 90s, when the first smartphone went public, it turned the world on its head. The IBM Simon was built by IBM and was one of the first instances of a handheld touchscreen device. Released in 1994, the IBM Simon went on to sell around 50,000 units in total. Although this did not create immediate change in the industry, people began to see the value of apps dedicated to tasks like instant messaging, and the rate of mobile development increased greatly. The early 2000s brought two important dimensions to the evolution of mobile apps. The consumer demand for a computer-like experience on a mobile device drove the development of the technology. One particular area that accelerated rapidly was touchscreen technology. All of this meant that operating systems had to provide more and more sophisticated platforms for apps to run on, and app stores were created to give users access to thousands of apps. The game-changing operating system Android made its appearance in 2003 and competed with the two giants of the time, Symbian and BlackBerry. And 2005 was a big year in the mobile world. It was the year when Google bought Android for about $50 million. In the meantime, smart devices became more advanced year after year and could run more sophisticated operating systems. The long-awaited iPhone was launched in 2007. This event marked an important growth in the Apple fan base. A year later, in 2008, the first Android operating system was released to the public. Android is the leading operating system used today. Now, let's cover a brief history of the main app stores. In 2008, Apple's App Store went online with over 500 apps. And in 2009, Samsung announced their App Store for mobile devices manufactured by Samsung Electronics. In 2010, Apple released their iPad with over 3,000 apps on their store. 2012 was another defining moment for app stores when Google rebranded their App Store as Google Play. And then in 2015, Google revolutionized its App Store. They introduced a system that allowed them to review apps before they are published on Google Play. Today, the mobile operating system market is largely dominated by two major tech companies, Google and Apple. Millions of developers around the world are building apps that run on their operating systems, Android and iOS. That was a brief history of the evolution of cell phones and mobile app stores. Have you ever scrolled through an app store and imagined how cool it would be to develop your own app? Fortunately, there are many tools and resources available to help you create iOS apps. Let's just cover how to do that. By the end of this video, you'll be able to explain iOS, one of the most popular operating systems in the world, identify the top integrated development environments or IDEs for iOS development, and you'll explore an example IDE to understand how they work. As a mobile developer, it's important to make sure that your app meets the requirements of the operating system it will run on. Otherwise, users may have a frustrating experience. As one of the most popular operating systems in the world, compatibility with iOS is a great standard to aim for. iOS is an acronym that stands for iPhone Operating System. iOS is based on an older Apple operating system called Darwin, which itself is based on Unix. All Apple's mobile devices run iOS. A prominent feature introduced on iOS devices is touch gesturing, which allows users to perform actions through such movements as swiping, pulling, and tapping. Apple devices also make use of accelerometers and gyroscopes, enabling users to switch between the orientation of applications. They can also react to the tilting of a device. This means that your app can detect if the user's device is placed vertically or horizontally and adjust itself to give the best view. This type of functionality has helped to greatly increase the iOS user base over the years. With this rise in popularity, Apple has given mobile developers more control and access to the features of iOS. So let's examine the history of the iPhone. iPhone version 1 was launched in 2007. From iPhone OS 2.0, developers had access to an SDK, or software development kit. An SDK is like a box filled with tools that mobile developers use to build apps for iOS. Version 3 brought huge improvements, such as call location for identifying where a device is, and push notifications to allow easy updates. iOS 4 was the first version to allow multitasking. And what about right now? The answer is that more improvements are continually being added. Now that you know a bit of the history, let's learn about the best integrated development environments, or IDEs, for iOS development. The first is Xcode, which can help you code faster by completing code lines automatically. It also has complete syntax highlighting for Swift, which is a language you'll learn about soon. Next, there is AppCode. This IDE from a company called JetBrains has a development environment that ensures fast and accurate execution of code. Another solid choice is Atom, which was designed and developed by GitHub. Atom is notable for its customizable environment and easy to install add-on packages. You should also consider Sublime Text. While this is a code editor rather than a full IDE, it is functional, clean, and fast, and features helpful built-in tools. Finally in the list is CodeRunner. This is an easy-to-use programming editor for Mac OS. It is quite a flexible IDE that supports a wide range of languages. Note that some of these IDEs are free, while others are designed for commercial use and require the purchase of a license. This should be considered when making the choice that best suits your needs. So now you know about some great options for IDEs, but how about programming languages? Which one is best suited for iOS development? While many are supported, let's focus on one of the most efficient languages for iOS development, which is Swift. Swift is a language created by Apple. It gives developers a single platform to create apps for the wide range of Apple devices. Xcode has supported Swift since the release of version 6 in 2014, making the two a popular combination for app development. Also note that the Windows operating system does not support Xcode. So, with the support of Xcode, mobile developers can use Swift language to develop engaging apps for Apple devices. Devices such as the iPhone, MacBook, and Apple Watch. Okay, let's demonstrate an iOS development IDE. I'll explore the Xcode IDE as it appears on the Apple MacBook. As you have learned earlier in this lesson, Xcode was developed by Apple to create software or apps for various operating systems, such as macOS, iOS, watchOS, and tvOS. It is also the only Apple-supported tool that can be used to create and publish apps to the Apple Store. In my layout, the coding window is found in the center of the screen, while the left window displays the folder structure and the individual files. This interface is beginner-friendly, but also allows for more experienced developers to work quickly and effectively. Xcode supports a wide variety of programming languages, including C++, Objective-C, Objective-C++, Java, AppleScript, Python, Ruby, and Swift. As Swift is the most commonly used language in Xcode, my example codebase is written with that language. It's great to know that it's a straightforward process to publish your app on the Apple Store. By using this IDE, you'll be able to develop, test, and deploy your app easily in an intuitive and seamless way. To recap, in this video, you have covered what is iOS and what are its requirements, what are the top IDEs that are used for iOS development, and lastly, what does the Xcode IDE look like in action? That was an introduction to the iOS platform, its IDEs, and associated languages. I'm sure you can't wait to learn more about building apps. There were once multiple competitors in the field of mobile operating systems, but currently just two dominate the market: Google's Android and Apple's iOS. While iOS has many dedicated users, it's actually Android that has the largest installed base of any mobile platform, with over 2 million new Android devices activated every day. By the end of this video, you'll be more familiar with what Android is, and will get to know some of the common tools and languages used to develop apps for it. So, what exactly is Android? Well, it's a mobile operating system that was first launched in 2008 and is the base system of many phones and tablets worldwide. Android is the largest installed base of any mobile platform. As a result, there is a large demand for apps to be developed for the platform. Apps are most frequently developed in an integrated development environment, or IDE, which is software that helps you build applications. It includes tools to write code and debug code, and may come with many other developer tools. There are a few IDEs available for creating Android apps. Here's a few important ones. Android Studio, which is great for building your app in a more productive way at scale. NetBeans IDE, which allows for development with Java. Visual Studio Code, also known as VS Code, which is a source code editor from Microsoft for Windows, Linux, and Mac OS. Finally, there is AIDE, which enables developers to create Java or XML-based Android apps using the Android SDK. In addition to choosing an IDE, you'll also need to decide on a development language, and Kotlin is a good place to start. Kotlin is a cross-platform language, which means it will work on multiple computing platforms. It was designed to replace Java for Android app development. Additionally, there are certain features that make Kotlin the best fit for Android developers. This includes compatibility, in that Kotlin-developed apps can run on older devices, interoperability, meaning that Kotlin and Java can both be used in the same project, shorter code compilation time, which allows faster work when adding code and testing code in small increments. And the language has the reputation of being easy to learn, especially for developers who are already familiar with other modern programming languages. Now that you know more about Android app development, let's explore an IDE to get a better idea of what you'll be working with in your future development role. This is Android Studio, a powerful and sophisticated IDE designed to develop, test, and deploy applications to the Play Store. It's the only officially supported IDE for Android development. It's an easy IDE for beginners to use, but it's also powerful enough for more experienced developers. Android Studio is comprised of a software development kit, or SDK, a collection of tools and other components. Android Studio supports two major programming languages, Java and Kotlin. In this demonstration, the focus will be on Kotlin. In the upper left part of the screen is the project panel, which shows how your project is structured and organized and provides quick access to project files. The software has a clear interface. Its features help you code and test more effectively. Features such as an intelligent code editor that analyzes for errors and a built-in emulator to simulate how your app would run on a real device. Perhaps one of the most useful features is the Java to Kotlin converter tool. This allows you to use a mix of Java and Kotlin code in a project, useful if you're moving from one language to the other. In this video, you learned about the popularity of the Android platform, the most commonly used IDEs for Android development, and the rise of the Kotlin programming language. Have you interacted with a web page on your computer or device today? If the answer is yes, then you have interacted with JavaScript code. You can think of JavaScript as a language of the web. In this video, you will learn how it works and how it is used to power your web and mobile applications. In the early days of the web pages were static, meaning they didn't have any interactions. Technologists envisioned that interactions and animations would be part of its future development. The American entrepreneur and founder of Netscape Communications, Mark Lowell Anderson, believed that web pages could be manipulated by using a scripting language, making web content interactive and dynamic for users. So the idea to build a language such as JavaScript was born. In the beginning, developers mainly used JavaScript to add interactivity to websites. For example, adding an item to your shopping cart on an e-commerce website. In recent years, JavaScript's popularity has grown, and it has become one of the most used languages worldwide. Technological advancements allow developers to now use JavaScript for a wide range of applications, such as web and mobile development, streaming services, and even games. Okay, so now you know what JavaScript is. Let's explore one of the main places you will find JavaScript. That's in the web browser. Typically, in programming, once you write some code, that code needs to be run or compiled into something called machine code to be understood by the computer. Browsers have a specific software component called a JavaScript engine that executes the JavaScript code and sends it back to the browser for rendering. So when a web page loads, the JavaScript browser engine does all compiling in the background. Then the web page is loaded successfully and users can interact with it. The JavaScript engine can also be referred to as the ECMA script engine. And typically, the companies that make web browsers have their own built-in JavaScript engine. For example, the JavaScript engine for Google Chrome is called V8. Mozilla Firefox uses SpiderMonkey, and Apple Safari uses JavaScript Core. Let's explore each of these now in a little more detail, starting with V8. V8 is Google's open source high-speed JavaScript engine. It is written in the C++ programming language and used in the Chrome web browser. This engine works with the most popular operating systems such as Windows, macOS, and Linux. Next is SpiderMonkey, which is the JavaScript engine of the Mozilla Firefox web browser. It's also developed in C++ and used to power Mozilla Firefox and other products. Finally, JavaScript Core is an open source web browser engine that allows developers to build a browser using its code. This engine powers apps such as the Safari browser used on macOS. Okay, now that you've learned about JavaScript and the JavaScript engine, let's now explore one of the reasons why JavaScript is so popular, and that's speed. Modern browsers can run JavaScript code much faster thanks to something called just-in-time compilation. This feature takes advantage of both compilation and interpretation of the JavaScript code. In this video, you learned about JavaScript and how it's the language of the web and is used to build web and mobile applications. Millions of websites are powered by JavaScript. As an aspiring developer looking to work with the web, JavaScript skills are essential. Are you ready to take the next steps and learn more about this exciting language? The internet is one of the most transformative and fast-growing technologies of modern times. Across the globe, billions of people visit websites from their web or mobile browsers every day. But have you ever stopped to think about the software that allows you to navigate sites from around the globe? That's right, I'm talking about the web browser. In this video, you will learn how web browsers give you access to content on the web. You'll also learn about the role that JavaScript plays in that and the differences between web browsers and mobile browsers. The internet has provided the means to access information and resources in the shortest possible time. By using a browser on a smartphone or computer, you can access websites from any part of the world in seconds. So, what makes this all possible? Let's explore and find out. You can think of a browser as an application designed to download a web page and present it in a way that is clear and understandable to a visitor. In order to access a website, two major things need to happen. First, the user enters the address in the browser's address bar. Then, the browser downloads the page and presents it in text, images, video, audio, and interactive elements. There are many browsers available, however, the market is dominated by just three: Google Chrome, Apple Safari, and Mozilla Firefox. Many websites allow users to interact with content, and JavaScript is just one of the technologies that make it possible. JavaScript allows you to alter just about every section of a page. This includes the content, the look and feel, and of course the response to user action. So now you know that JavaScript plays a crucial role in offering users a good browsing experience. But what does JavaScript actually do to make this all happen? Well, when a browser downloads a web page, it is received as code, specifically HTML, CSS, and JavaScript. But this code needs to be turned into a page that users expect to see. This is where the browser comes in and uses a JavaScript browser engine to do the job. Depending on the browser, JavaScript engines can have different names and may not work in exactly the same way. Now that you've covered how browsers work, let's explore the major differences between mobile and desktop browsers. Some of the key advantages of mobile browsers are that they allow quicker web page access, they enable seamless multitasking, they are also very portable, they are usually updated regularly to improve the user experience. and they consume less data bandwidth. Some major benefits of desktop browsers are that they are generally more stable, they allow a larger view of a web page, they allow full access to website content, and make it easier to navigate between pages. In this video, you learned how browsers download and present the web content that you access every day. You also covered how JavaScript improves your experience and the key differences between mobile and desktop browsers. I'm sure you, like most people, expect a great user experience when you use the web. But have you ever wondered how the size of a website can so easily adjust between different devices, like laptops and mobile phones? Well, the answer is responsive design. Responsive design means that a web page can automatically stretch or shrink depending on the screen it's displayed on. In the past, developers had to create two versions of a website, one for desktop and one for mobile devices. This was expensive and time-consuming, so responsive design was developed to solve these issues. As a developer, you will probably work with responsive design every day. Let's explore how it works. After watching this video, you'll be able to explain how responsive design is used to provide the best user experience based on the device that the website is viewed on. Describe CSS media queries and screen resolutions. Classify fluid images and differentiate between fixed and fluid grids. Phone, tablet, and computer screens, including the one you're probably using right now, are made up of thousands of tiny lights called pixels. The resolution of your screen refers to the number of pixels it contains, most often expressed as a number of horizontal pixels multiplied by the number of vertical pixels. For example, a common computer screen resolution is 1920 pixels in width and 1080 pixels in height. Thanks to responsive design, media queries can determine the resolution of a screen and instruct a website to use the best layout. However, today we have many different screens with different resolutions, which is why responsive design is so important. And it is complicated by new high-resolution screens like the one found in your mobile phone. Responsive design is a set of 3 techniques that allow a website to automatically change its visuals. In other words, to respond based on the device it's displayed on. Responsiveness is created by a combination of the 3 techniques: flexible grids, fluid images, and media queries. First, instead of defining website element sizes based on pixels, flexible grids are defined in percentage values, allowing them to adjust depending on screen size. This will determine the percentage of space each element will take on the screen. Second, when set correctly, fluid images allow images to scale down to a smaller size, but not grow larger than its original size and become lower quality, what is known as pixelated. The scaling depends on the screen or window size of the display device. Finally, media queries allow developers to query the display size, orientation, and aspect ratio of the device to help the website display properly. When used together, flexible grids, fluid images, and media queries allow you to build a website that will automatically adjust its layout based on the device, thus delivering a responsive grid. In responsive design, the pixel value specified is often referred to as the breakpoint. A breakpoint is the point at which a website's content and layout will adapt to provide the best possible user experience. Remember that responsive design also applies to presenting the best user experience across platforms. With that goal in mind, developers use cross-platform mobile development frameworks to create products that run on multiple platforms like iOS, Android, and Windows. These frameworks include products like React Native, Angular, Flutter, and Appcelerator. In this video, you covered responsive design and how it helps developers build products that offer the best user experience across multiple devices. You've reached the end of this module on mobile applications. Over the course of this module, you've explored web and mobile or cross-platform developer roles, the basics of how the web works, and familiarised yourself with key concepts in mobile development. Let's take a few moments to recap the key lessons and skills that you gained along the way. You started the module with an overview of cross-platform developer roles, and you can now outline the role of a cross-platform developer by listing some of their common day-to-day tasks. These include design, planning, research, building, and maintenance. You can also identify several of the businesses and areas in which cross-platform developers share their skills, like startups, agencies, and Meta. And you're able to explain the languages and skills that cross-platform developers require to succeed, like JavaScript and user interface, or UI development. Next, you moved on to explore the basics of how the web works. In this lesson, you familiarized yourself with the technologies that power the internet. Having completed this lesson, you can now identify what a network is and demonstrate an understanding of how the internet works, identify the client-server model, and explain the request-response lifecycle. You also explored the basics of key concepts like web pages, web servers, and web browsers. In terms of web pages, you can now differentiate between a website and a web page by outlining the key elements of each, outline the purpose of HTML and CSS, and provide an explanation of how they work, and identify the benefits that JavaScript provides to a web page, like interactivity and data processing. You're now familiar with the basics of web servers and can explain how a data center provides storage and power for web servers, differentiate between the key functions of web server hardware and software, and outline how a web server handles requests through HTTP or Hypertext Transfer Protocol. And you also investigated the third key technology of the web, which is web browsers. Following this investigation, you can now explain what a web browser is, describe how a web browser receives content from a web server and displays it for users, and outline the request-response cycle. This includes identifying how languages like HTML, CSS, and JavaScript generate and interact with web pages. The final lesson that you undertook in this module was an introduction to mobile development. During this lesson, you explored key concepts around mobile applications, like development platforms, languages, and interactivity. Having completed this lesson, you can now explain the importance of mobile technology to everyday life, outline the development of mobile technology over the last few decades, and identify major mobile operating systems like Android and iOS. As part of your journey to become a mobile developer, you also explored mobile operating systems like iOS and Android. As a result, you learned how to explain what iOS is alongside its benefits, identify the leading integrated software environments or IDEs for iOS applications such as Xcode, and outline the purpose and function of the Swift programming language. Explain what Android is, outline the leading integrated software environments or IDEs for Android applications, and identify the benefits of the Kotlin language in Android Studio. You investigated JavaScript and learned how to explain the purpose of JavaScript and provide a brief overview of its history, outline how JavaScript interacts with the browser in order to generate interactivity, and identify some of the unique JavaScript engines utilized by major browsers. You studied mobile and web browsers and can now describe how a browser downloads and renders a website, outline how JavaScript enables interactivity in a web browser, and identify the advantages of mobile and desktop browsers. And finally, you explored responsive design and learned how to explain the concept of responsive web design, describe how responsive web design works, and outline the advantages of responsive web design. You're now familiar with mobile applications, including common web and mobile developer roles, how the web works, and the basics of mobile development. That's a great start to your React Native journey. Well done.
When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is. It always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story about where it all started. Sir Tim Berners-Lee, a physicist, often thought about how he and his colleagues from around the world would share information. You are so used to browsing information online that it might seem a silly thing to ponder about. Actually, that question was very relevant at the time and started the development of HTML. Would you like to explore the very first web page? I know just where to find it. The first web page was created in 1989 by Sir Tim Berners-Lee. He worked at the European Organisation for Nuclear Research, or CERN, and originally proposed HTML. The first version of HTML was released in 1991, along with the first web browser and web server. HTML stands for Hypertext Markup Language. But what does that mean exactly? Hypertext is text which contains links to other text. Markup refers to tags and elements used within a document. For now, let's just focus on some of the basics of HTML. HTML is simply a text file with a specific structure that consists of elements and tags. Also take note that HTML files usually have a .html suffix. For instance, when you visit a website, the first page that is returned to the browser is often called index.html. Now, let's explore what HTML tags and elements are. Each HTML element consists of an opening tag enclosed in angle brackets. For example, to create a paragraph, you type a left angle bracket, the letter P for paragraph, and then a right angle bracket. Most elements are paired with a closing tag, which has a / after the left angle bracket. For example, you close a paragraph element with a left angle bracket, a /, the letter P, and a right angle bracket. HTML elements usually have some content inside them. For example, between the opening and closing tags of a paragraph, you add the text of the paragraph you want to write. HTML elements can also contain other elements. For example, you can add an italics element inside a paragraph element to make text appear in italics. But elements can also be empty or self-closing, meaning they do not have a closing HTML tag. One example of a self-closing element is the line break tag. You can add a line break tag in a paragraph tag to move content to the following line by typing left angle bracket, the letters BR, then right angle bracket. At the end of a self-closing tag, you simply add a right angle bracket, but you can also close the right angle bracket by typing a / right before it. Now that you know what elements and tags are, you will explore what HTML standards are. The rules and structure for elements and tags are known as the HTML specification. The HTML specification is maintained by the World Wide Web Consortium, or W3C as it is commonly known. Whenever the HTML specification changes, a new version of HTML is standardized. The current version is HTML5. So to summarize, HTML elements with their opening and closing tags in angle brackets build up an HTML document. These elements form the structure of a web page and describe to the web browser what to display. For example, the browser reads an HTML page that has an image tag to display an image file called icon.png. Next, it reads a p tag to display a paragraph under that image. But the browser reads the HTML document and displays the web page to the user in a very basic format. Now, if you want to tell the browser how to display the web page, you should use CSS. You will learn more about CSS in this course. By now, you have learned how HTML tags are used to create elements that build the structure of a web page. You will have an opportunity to explore HTML in action in this course.
In this video, I will guide you through the blueprint of an HTML document. I will create a very simple web page for a restaurant called Little Lemon. The great thing about HTML documents is that you don't need the web to view them. Yes, they don't have to be hosted on a web server for you to view them in your web browser. You can save HTML files on your computer and view them locally with your web browser, almost like eating takeaways at home. So by the end of this video, you'll be able to identify the structure of an HTML document and create a basic web page. To create an HTML file in Visual Studio Code, I right-click in the Explorer panel and select New File, name it index.html. By now, you know that HTML documents are made up of elements and tags. But before I can add elements or tags, I first need to create the standard HTML structure, which starts with the doc type declaration tag. This notifies the web browser that it is an HTML document. Next, I create the HTML tag, which is also known as the HTML root element. And inside the HTML tag, I add the two main elements, the head and the body elements. It's important to note that nothing inside the head element is displayed as a web page in the web browser. In the head section, you add information or metadata about the HTML document. It is not part of the content of the web page. For example, inside the head tag, you always create the title element. This is the title that is displayed in the web browser tab. I can also link to CSS files and define meta tags in the head section. Meta tags can, for instance, specify the description of the web page, keywords for search engines, and the author of the web page. Next up, I add the content of the web page inside the body tag. The body can contain elements such as headings, paragraphs, images, and videos. Okay, let me start by adding a main heading on the web page by using the h1 tag. Inside the h1 tag, I type the heading Our Menu. That's good. Now I need to start creating my menu. I want to add 2 items, so I add 2 subheadings. For this, I use the h2 tag. The menu items in the subheading are falafel and pasta salad. But first, I need to save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Now I right-click on the index.html file in the Explorer panel and select Reveal in File Explorer. If you're not using the Windows operating system, this may be called Reveal in Finder or Reveal in File Browser. Now the file browser opens and lists the file. I double-click on the index.html file and it opens in the web browser. Great, it's all here. The title that displays in the Browser tab matches the title that I added to the head section, and the content is displayed in the browser window, but it is still a bit empty. I go back to Visual Studio Code and add a short description for each dish. I do this by adding the paragraph tag below each subheading H2. Let's imagine a nice falafel. I type chickpea, herbs, and spices. What goes in a pasta salad again? Lettuce, vegetables, and mozzarella. Yummy. I save the file to update the changes and open it in my web browser again. There you go. Now the ingredients are also included in the menu. Some of the best websites are websites about food. Whenever you need some inspiration, search for food website ideas online. You'll be fascinated. Now that you know some basic HTML tags, try to identify where they were used in those websites. There are many HTML tags that you can use in your web pages, but you are now familiar with a few elementary ones, and I encourage you to start practicing with them. Best of luck.
By now, you should know how to build a basic web page. But how do you build a website? Remember, websites consist of multiple web pages linked together. To link pages together, you use the anchor tag. Anchor tags create hyperlinks, or links as they are commonly known. In this video, you will learn how to link different web pages together to create your own website. In my project folder, I now create a second web page for Little Lemon that will contain the address of the restaurant. I right-click in the Explorer panel to create a new file and name it location.html. I use the same file structure created in my index file, but add new content. I add a new h1 tag for the heading and type our location. Next, I add a paragraph tag and insert the address 123 Home Road, Main District, Capital City. I press Ctrl and S to save the file or Command and S on a Mac. Now that my new file with the restaurant location is created, let's navigate back to index.html file to add a link from there to the location.html file. Below the last paragraph tag, I add the anchor or A tag, followed by the href attribute or hypertext reference. Now I need to specify where the hypertext reference should link to. I type the file name, location.html, so that my index.html file will link to it. Within an A tag, I can also add a descriptive text that is displayed as the link name on my web page. So I type our location. The text our location will now display on the web page in the browser as a clickable link. Let's test if it works. I save the file to update it with the changes and open it in my browser by right-clicking on the index.html and selecting Reveal in File Explorer. If you're not on Windows, this may be called Reveal in Finder or Reveal in File Browser. Then I double-click on the index file. The words "our location" are displayed in blue in the web browser. Success! If I click on the blue link, the browser opens the location.html file. You can now link different HTML files together to create your website. Best of luck. Imagine your favourite social media site. If it was just an HTML document, users would be able to scroll the page, look at pictures and read text, but they wouldn't be able to log in, like posts, or get notifications for new messages. In order to allow users to do these things, they need to be able to interact with objects on the page, such as the reaction icons or the comment button. Or, let me put it differently. An HTML document must be represented in a certain way so that JavaScript code can query and update it. To do this, we use the document object model. In this video, I will unpack what the DOM is, how it is created, and how JavaScript interacts with the DOM to make sites dynamic. When your web browser receives an HTML page, it constructs a DOM to represent it. DOM stands for Document Object Model, and it is simply a tree structure or model of the objects in your HTML file. To understand the DOM, I want you to think of a simple HTML page. Remember that an HTML document has opening and closing tags for the document and the head, and inside the head tags you have title tags. Then you have the body, and inside the body there might be elements such as div tags. Okay, now let me guide you through how a DOM would be generated. The DOM has a series of objects, each representing a single HTML element. At the root of the DOM is the HTML object, and it contains the head and body object. From there, the head object houses the title object, and the title object contains its text object. The body object contains the two div objects. The first div houses the heading 1 object, which again houses its text object. The second div object contains the paragraph object, which contains its text object. In summary, all the elements in the HTML file are represented as objects in the document object model. I just took you through a very simple web page. Web pages typically have hundreds of elements. Can you imagine how complex the DOM of a highly interactive modern web page is? You as a developer can use JavaScript to access and modify the DOM to make your web pages dynamic. In fact, in a later course, you will learn how to access and modify the structure of the DOM and its elements in different ways. Now that you know what the DOM is and how it is referenced, let me briefly explain common DOM and JavaScript uses. For each element, you can access the HTML attributes and content. This means you can update the existing content that is displayed in the web browser. For instance, you could write some JavaScript to update the seconds, minutes, and hours of a digital clock on a website. Or, if you develop a movie streaming website, you can write code that responds to user actions such as clicking, mouse over, scrolling, and so on. In this way, you can allow a preview of the movie to play when the user hovers the mouse over the movie's poster. Or, you can think of a login page. When users click the login button, you can disable the button so that it cannot be clicked again. The web application would bring them to a new web page or would re-enable the button if a login error occurred. You can even add DOM objects to dynamically add new HTML content to a live web page. For instance, you can add an error message to a form if the user inserts invalid data. DOM objects can also be deleted, which will remove the corresponding HTML displayed in the browser. Think of a to-do list on a website. You can remove an item from the list when the user clicks on it. Another major use of JavaScript and the DOM is to animate the HTML elements. This can be quite complex depending on the animation, but there are many libraries available that aim to simplify this. For example, when a page first loads, you can fade in the page contents. Or, when a user receives an instant message, a notification can pop up in the web browser. Many JavaScript libraries and frameworks rely on the DOM. One of these libraries is the React library. By now, you know what the DOM is, how it is constructed, and the wonderful things web developers can do with it to create modern interactive websites. Next time you use your favourite social media site, think about how the DOM is working behind the scenes to change the colour of that like button. As a web developer, you should try to ensure that everyone can access and enjoy the internet. almost like an architect that needs to design a building with ramps and rails so that it is accessible by all. You need to build a website in a certain way to improve accessibility. When the Web Accessibility Initiative, or WAI, was launched in 1997, the creator of the World Wide Web, Sir Tim Berners-Lee, said, "The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. Web accessibility aims to allow people with disabilities to understand, navigate, and interact with websites. A common misunderstanding is that it refers to visual disabilities, but in fact, it includes all disabilities that affect interaction with websites, such as audio and visual disabilities, cognitive and neurological disabilities, and physical and speech disabilities." The W3C Web Accessibilities Initiative develops specifications and supporting resources for accessibility. These are considered international standards for web accessibility. In fact, web accessibility is becoming a requirement in many industries. In 2016, the European Union approved the Web Accessibility Directive, which requires websites and mobile applications of public section bodies to be accessible to those with disabilities. Let's explore some examples of how accessibility is provided to those with different disabilities. People living with disabilities often use assistive technologies to aid them in browsing the web. Screen reader software can read the content of websites and everything that is happening on the device. Screen readers are used not only by blind and vision impaired users, but also by those with reading or learning difficulties. Speech recognition software can turn spoken words into computer commands or dictate inputting text. This is useful for people who may not be able to use a mouse or keyboard due to physical or neurological disabilities. Subtitles and video scripts in videos provide assistance to those with audio and visual disabilities. There are many steps that you can take to improve accessibility. It is good practice to think of accessibility from the beginning of a project. It is a lot harder to rework the project to be accessible later on. If you use the correct HTML structure and appropriate elements as a foundation, it will greatly improve accessibility. In this course, you will learn to structure your HTML properly and follow best practices to support assistive technologies. For example, having text that is not contained within proper tags, like paragraph or heading tags, makes it harder for assistive technologies to interact with the content. Similarly, using multiple line breaks to break up text and add space also presents barriers to accessibility. These are just simple examples to improve web accessibility. However, in the future, you'll probably develop very complex user interfaces, and to make them accessible may not be as straightforward as just having correct HTML. Fortunately, one of the tasks of the WAI is to define the Accessible Rich Internet Application, or ARIA specification. The ARIA specification outlines different techniques to improve accessibility for complex web apps. Now you know about different assistive technologies and that you should use the correct HTML structure and appropriate elements to improve accessibility. I'd like you to think of a physical building and its structure, interior, exterior, and decorations. In a similar fashion, when it comes to websites and web apps, you can think of HTML as being the frame and structure. CSS, however, is the paint, wallpaper, fixtures, artwork, and overall style or look and feel. In other words, CSS tells the web browser how to display HTML elements on screen. When using CSS, there are 5 elements you need to understand. A declaration block starts with a left curly bracket and ends with the matching right curly bracket. In between these curly brackets are the style declarations. Let's cover these elements one by one. The first element of the CSS rule is the selector. This indicates which HTML element or elements you want to style. For example, you can create a rule that uses the H1 selector to change the color of all heading 1 tags in a web page to grey. In this case, H1 is the selector, color is property, and grey is the value of the property. You then create a declaration block using opening and closing curly brackets. The declaration block holds information about the properties and values that you are going to apply to the selector. Now let's focus on the structure of the declaration block. Each declaration is made up of 2 parts, a property and a value. For example, in this case, the properties that you want to change are the color and the background color of the header or selector. Once you have decided which properties you want to define, then you must assign each property a value. The color property gets a value of blue and the background color property gets a value of grey. This will result in all heading 1 tags displaying blue text on a grey background in the browser. By now, you'll have learned that CSS tells the web browser how to display HTML elements on screen. Now, let's work through an example to change a set of heading elements using different CSS rules. I will share a pro tip demonstrating how to install and use the VS Code extension Live Preview to speed up your workflow. Okay, so I'm back in Visual Studio Code here. Did you know that you can add additional functionality by using extensions? If you click on the Extensions tab, you can install the Live Preview extension by Microsoft. If you are running VS Code locally, you can install and use this extension. Once installed, right-click on your HTML file in the Explorer panel and select Live Preview, Show Preview. When you update an HTML file, you immediately notice the changes in Visual Studio Code. In this video, I will demonstrate how to create a CSS file and style some HTML elements. Before I start styling elements, let's create a simple HTML document named index.html. To demonstrate how CSS works, I will use an example created previously. Next, I create a file named style.css. For my web page to use the CSS file, I need to link it to the head element of the HTML file. To link to a style sheet, you use the link tag, which must be assigned 2 attributes, rel and href. The rel attribute is assigned to style sheet, and the href attribute is assigned to the name of the style sheet file. In this example, it's style.css. I am now ready to apply CSS to the index.html file using style rules that I will write in the style.css file. The selector I'm creating applies the CSS rule to all H1 elements. This type of selector is called an HTML type selector. The properties in the declaration block allow me to change how the selected elements are displayed. For example, I'm setting the color property of all the H1 elements to display text in purple. I save the file using Ctrl and S. Notice that this change occurs immediately and there is no need to refresh the web page. So now, what if I want to only style a single H1 element? I can add an ID attribute to the H1 tag that I want to style, and in my CSS file, I create a rule for that ID. Let's do that now. First, I create an ID rule using the hash symbol and then the name header 1. Then I define the CSS properties of that rule to change the color value to green. I apply the rule and save the file using Ctrl and S. Notice that the text for the heading Chapter 1 on the web page turns green. You may be wondering, why does the first CSS rule not apply to the H1 element with the ID? This is because of something called CSS precedence and specificity. This is a complex statement, but basically, the browser will use the most precise selector for an HTML element. CSS has a set of hierarchy rules which dictate which rule will apply to an element. In this example, the ID rule takes precedence over the HTML type selector rule. You can learn more about CSS selector rules and precedence from the additional reading at the end of this lesson. Congratulations! You have now learned about the selection and styling in CSS. Let's quickly recap. After choosing a selector for your styles, you create a declaration block using opening and closing curly brackets. Inside of the code block, you write a declaration which consists of a property value, pair ending in a semicolon. And all these parts together, the selector, code block, and declaration make up a CSS rule. I encourage you to add some CSS rules to your HTML documents to practice selecting and styling. Just like a busy day at a restaurant, a website can easily look squashed and busy. With waiters having to maneuver their way around and customers' chairs up against each other, it can get messy. Good restaurants usually have carefully planned layouts to make customers feel comfortable and allow waiters to move around with ease. Sometimes, creative web development requires thinking inside the box. In this video, I will demonstrate how to use the box model in CSS to create an appealing layout and allow users' eyes to easily flow between content. When an HTML document and CSS style sheet are downloaded, the web browser needs to know how to display the elements on screen. To do this, it allocates a rectangle or box to each element. CSS rules are applied to the boxes of the elements. This is known as the box model. Every box consists of 4 parts: the content, the padding, the border, and finally, the margin. The content is the actual content of the element, like the text or the image. Its size is known as the content width and content height. Browsers are clever, and by default, they will calculate the width and height based on the content itself. Fortunately, developers can control the size to manipulate the layout. You can do this by applying CSS rules to the content, such as width, minimum width, maximum width, height, minimum height, and maximum height. Let's move on to the padding. The padding extends the content size. Its size is known as the padding box width and the padding box height. The thickness of the padding is determined by the padding top, padding bottom, padding left, and padding right. The padding box width can be calculated as content width plus padding left side plus padding right side. And you can calculate the padding box height by adding the content height, the padding top side, and padding bottom side together. Next, let me show you how you set the border. The border goes around the padding and content. Its size is known as the border box width and border box height. You can set different types of borders, such as solid border or a dashed border. To understand how this plays out practically, I will demonstrate the HTML, the CSS style, and the physical border. To set the border, you can write border width thin, border width medium, and border width thick. Now, let me share with you a pro developer tip to help you calculate the size of your HTML elements when working with the box model. An HTML element is equal to the size of the border box. To get the border box width, you add the padding box width plus the border left side plus the border right side, and you can calculate the border box height by adding the padding box height and the border top side as well as the border bottom side. Lastly, let me show you how to set the margin. Following on from what you have just learned, do you have an idea of what the CSS rule might be? The margin extends the border area to separate the element from its neighbouring elements. Its size is known as the margin box width and margin box height. To specify the margin sides, you write margin top followed by the value. The margin bottom, margin left, and margin right follow the exact same notation. You can also set the padding, border, and margin with shorthand properties, but more on this later. Lastly, let's calculate the size of the margin box. Can you guess how? The margin box width can be calculated by adding the border box width, the margin left side, and the margin right side together. To get the margin box height, add the border box height, margin top side, and margin bottom side together. To easily remember this, think of the content as yourself. The padding is like the thickness of your clothes. The border is like the silhouette or outline, and the margin is the personal space between you and another person. In this video, I've opened the box model for you. Inside it is the content, and around it flows the padding. The border fits around the padding, and lastly, the margin is the empty space keeping elements apart. You will work with the box model in every website you develop, so I encourage you to start practicing with it in your designs. By now, you've learned how CSS styles individual HTML elements. But how does the web browser know where to place the elements on the screen? The web browser's normal way of calculating the position of HTML elements on the screen is called document flow. By default, nearly all HTML elements are organized into one of 2 categories, namely in block and inline elements. A block-level element will occupy the full horizontal width of its parent element and the vertical height of its content. Each block-level element will have a new line before and after. Therefore, multiple block-level elements will stack on top of each other like a stack of boxes. Inline elements only occupy the width and height of their content. They don't appear on a new line, hence the name inline. Therefore, multiple inline elements can form a row of elements. When coding in HTML, you need to be able to recognize and use block elements. Some examples of block-level elements include the tags div, form, and heading. You also need to be familiar with common inline elements. These include the tags anchor, image, input, label, bold, italics, emphasis, and span. Let me demonstrate the difference between block and inline now by using an example of an HTML file containing div and span elements. Okay, so I've opened Visual Studio Code here. I will now demonstrate an example where you will learn about document flow. First, I want you to notice that I have a div element containing 3 sentences of lorem ipsum. A div or divider element is used to divide content into sections. If you don't speak Latin, don't worry. Lorem ipsum is placeholder text that has been used since the 1500s. Each sentence contains a span element that you may recall are inline elements. Notice that all text is displayed in an unbroken flow of content in the browser. In the code, I have div and span elements. I am now going to change the middle sentence from a span to a div tag. Because the div tag is a block level element, notice that the sentence has been moved to a new line and the span element after it is also on a new line. It's possible to change elements from block level to inline and vice versa. This can be done using the display CSS property. Let me add a CSS file called style.css. In my HTML file, let me give the middle sentence div element an ID. I now add a rule in the CSS file to change the element to an inline element. To create the CSS rule, I type #middle and open the curly brackets. On the next line, I type display : space inline semicolon, and on the next line, I close the curly brackets. Notice that the div has now changed to an inline element. If I want to change it back, I can just remove the property. I have deleted the rule in the code to change the element to an inline element. Another way to achieve this outcome is to set the display property to block. I have now changed the value for display to block. In another video, I'll demonstrate to you that there are other values you can set for the display property to change the layout behavior of an element. Congratulations! You have now learned about block and inline elements in HTML. It's important for developers to be comfortable working with each and to know the differences. It's vital to keep in mind that block elements start on a new line and span the entire page, and inline elements work within the flow of the surrounding content, rather than breaking onto their own line. If a car breaks down, you can open the hood to examine the engine and to find out what's gone wrong. As a developer, if your front end isn't working as expected, you can also open the hood to check what's going wrong. In fact, it's not just your own code that you can investigate. How about viewing other people's code? By the end of this video, you'll be able to access and make use of common web browser developer tools. Most web browsers come equipped with a set of developer tools that allow developers to inspect their HTML, CSS, and JavaScript code. Also, to trace HTTP requests to the web server, investigate performance issues, and review web page security. Let's find out more by exploring the homepage of the Little Lemon Cafe. To begin, I've just opened the Little Lemon Cafe's web page on my Chrome browser. On the homepage, I can view their menu, but I want to explore the HTML structure of this menu. To do that, I need to open the developer tools. To open the developer tools in Chrome, press the F12 key on your keyboard for PC or Command-Option-J on Mac. Alternatively, you can right-click on the web page and select Inspect. There are various tabs on the top row of developer tools that provide different functionality. In this video, I'll give you a high-level explanation of some of the most used tools. First, let's open the Console tab. This tab outputs JavaScript logs and errors from your web application. The Sources tab shows all content resolved for the current page. It includes HTML, CSS, JavaScript images, and videos. With the Network tab, you can inspect the timeline and details of HTTP requests and responses for the web page. The Performance tab shows what the web browser is doing over time. It is useful if your web application is running slow because you can pinpoint the functions that are taking the most time. The Memory tab displays the parts of your code that are consuming the most resources. Finally, let's check the most used tab, the Elements tab. You can use this tab to inspect the document's HTML elements and their properties. For example, when I hover over an element in the Elements tab, it highlights that element in the browser pane. On the right side of the panel, there are tabs for inspecting the details of the elements further. This panel shows us what CSS is applied to an element and the result of the element displayed in the browser. You will explore these details in a later lesson. For now, you just need to know that if you click on an HTML element, then the information for that element will appear in the tab. Now, I'm going to demonstrate a fun trick. If you double-click the HTML, you can edit it in the web browser. For example, if I select the R menu body element, then I can change the first item in the menu from chicken burger to turkey burger. This doesn't change the content on the web server. It only updates it for me while the web page is open. If I open the web page again, it will reset. The web browser developer tools are a valuable part of your development toolkit to help you investigate and diagnose problems. And you now know how to access and make use of them. Great work. Think of a group of construction workers. Every worker has a toolbox that helps them get their job done. As a developer, you'll also use many tools. One of the main tools in your toolbox is the Integrated Development Environment, or IDE. By the end of this video, you'll be able to identify an IDE and explain the benefits of using an IDE during development. An Integrated Development Environment, or IDE, is software for building applications. An IDE is just like a text editor, except instead of writing documents, you're writing code. There are many IDEs available. Some are specific to one programming language, while others support many languages in one IDE. Let's explore some common IDE features. Here I'm working within an IDE. First, let's cover syntax highlighting. To improve readability for developers, IDEs have syntax highlighting. What this means is that special keywords of the programming language are highlighted in different colors so that the developer can quickly differentiate these keywords from other text. For example, if you're writing JavaScript code without syntax highlighting, it could be harder to identify keywords from other text. With syntax highlighting, that gets much easier because the JavaScript keywords and variables are colored differently. Now, let's explore error highlighting. Just like checking spelling in a text document, IDEs can highlight mistakes you make in your programming code. For example, if I delete the equal symbol where it's needed, my IDE will highlight the error. Another feature of IDEs is autocomplete. When you're typing a message on your phone, it suggests words as you type. An IDE's autocomplete is a similar feature. Since programming languages have special keywords, IDEs can offer suggestions to autocomplete words as you start typing them. Additionally, another feature called IntelliSense can make IDEs very smart and even able to understand your code. They can detect variables and functions and offer them as suggestions during autocomplete. For example, if I have a JavaScript function named myFunction defined at the top of a JavaScript file, then as soon as I start typing the letter M, my IDE suggests this function as an autocompletion. Then there is refactoring. Since IDEs understand your code, they can help you if you need to change it. To demonstrate how refactoring works, let's continue with the myFunction function that I defined a moment ago. In the code, the function is then called multiple times. It can also be called in the code of other files too. But what if you need to rename this function? You would need to rename it in every file that uses the function, ensuring that you update those files to use the new name. This process is known as refactoring, changing the structure of the code without changing the functionality. Doing this manually is very time-consuming and prone to error. If you mistype the new function name in one place, the application will break. Since the IDE understands your code, it can assist with refactoring and automatically update the function name across all files. That saves a lot of time. Let's rename our function now. I just right-click on the function and select Rename Symbol. Then I change it from my function to our function. The IDE then updates all references of that function name. IDEs come with a lot of other features to help investigate bugs and collaborate with other developers. Many even allow you to extend their functionality using plugins and extensions, but that's beyond the scope of this lesson. You have explored some features of IDEs in this video. You now know how IDEs operate as part of a developer's toolbox to write code more effectively. Well done.
Mobile devices are part of our everyday lives. Instead of using desktops and laptops, People now use their mobile phones and tablets for everyday tasks like shopping online or booking holidays. This type of activity has become much easier. This is because the mobile versions of websites now provide the same user experience as if you were using a mobile application. And this improvement is thanks to the push toward cross-platform app development. Recall that cross-platform development produces a single application that can be deployed or used on multiple operating systems, such as iOS, Android, and Windows. There are multiple tools and technologies available, all of which have their roots in web development. In this video, you will learn about why cross-platform app development is important for teams building web and mobile applications. But first, it's helpful to understand why this came about. This began when it became possible for users to access the internet from a browser on their mobile device. The new preference to browse the web on mobile led to the development of mobile-friendly websites. These websites were a separate implementation of the standard or desktop website. Having two separate websites meant that it was time-consuming and expensive to produce web-based content. Then, in 2017, search engine results started prioritizing mobile-friendly websites. This was known as mobile-first indexing and led to the development of best practices for mobile-first design. Mobile-first indexing caused the rapid development of new technologies to ensure that desktop web content was easily accessible on a mobile device. And this led to the development of responsive websites. A responsive website can alter its layout, depending on the screen size it's being displayed on. The website content can automatically adjust based on the screen size or orientation of the device viewing it. However, responsive website developers also had to deal with the limitations of mobile devices in terms of memory and processing power. Another limitation is that all user interface or UI elements were provided by the website content rather than by any of the mobile device UI elements. While these websites performed well, they weren't quite the same across different platforms. There were differences in rendering, navigation, and user interface options. For example, a responsive website viewed on iOS may differ from a website viewed on an Android device. A better solution was needed. So, large organizations introduced dedicated mobile app versions of their websites that can be downloaded directly to user devices. However, this introduces a new problem. For development teams working on this mobile app development, they now had to consider the different operating systems. For example, if you wanted an app that worked on Android and iOS, then you needed to create two native apps. This meant that two development teams had to work on the same app using different code bases. As a result, the development cycle was longer and more costly. For example, the development teams had to create separate apps for Google Play for Android, the App Store for iOS, and the Microsoft Store for Windows Mobile. Separate development for separate platforms was not ideal, and multiple techniques were developed to address the problem. The first solution was web apps that could be installed on a device but could still deliver their content over the network. However, these apps couldn't be installed in the same way as native or platform-specific apps. Instead, they existed inside the browser and still required an internet connection to function. Although web apps could use some of the functionality of the device they were accessed on, they depended on a web browser. Because of this, the experience could be different depending on the browser used. One is a Progressive Web App, or PWA. This allows for greater integration with the device. PWAs can be installed on multiple types of devices, and they can access most of the built-in features of the device. However, PWAs still use web technologies and require the browser's engine to run. Another solution is cross-platform application development. Recall that cross-platform developers make software applications that are compatible with multiple operating systems. The development of this specific technology has led to a number of options. One of these options is React Native. Recall that React is a JavaScript library that is primarily used to build websites and user interfaces. React, combined with the use of React Native framework, allows for the development of cross-platform apps. Using a single code base, developers can make apps that work on web and mobile devices regardless of the operating system. These apps can access device hardware as well as use the native or built-in operating system UI elements. This type of software development allows for the user experience of the app to be maintained regardless of the platform used. In summary, cross-platform development provides a way to access hardware or operating system-specific components through a common developmental approach using a single code base like React.js and React Native. This has streamlined the mobile software development cycle and made it easier and more cost-effective to create apps that work the same across different devices. There have been many instances in which developers have reached the end of a project only to realize that a quicker or easier method could have been used. That's why it's important that developers know the pros and cons of their development process. With a cross-platform development process, for example, there are many advantages and disadvantages to be aware of. Over the next few minutes, you'll learn how to identify the advantages of cross-platform app development and be able to identify the disadvantages. One of the many benefits of cross-platform development is that you only need to learn one language to have the ability to create applications for multiple platforms. Another effect of cross-platform development is the decrease in project costs. Let's begin by exploring the methods that lead to this cost reduction. Only one development team is required, which significantly reduces cost. And apps can move to market quicker because they take less time to develop. Apps are developed using the one common language, which also reduces required resources. There's no need to write unique code for both iOS and Android. The same code can be used for multiple platforms. Bug fixes for code only need to happen once, and the use of common development tools across platforms also leads to a more uniformed and seamless user experience. Another key advantage of cross-platform development concerns the marketing efforts required to launch an app. Cross-platform apps only require one marketing campaign, but native apps require a separate campaign for the users of each platform. Apps developed for multiple platforms can launch across all operating systems on the same date with maximum exposure. And a unified release date means that all users can be reached at the same time. Cross-platform development also makes things easier after initial app development has completed. For example, cross-platform development means that you can synchronize maintenance. So you only need one update for both platforms. And the increase of bring your own device, or BYOD culture, means workplaces can increase the early adoption of work apps. As you've just discovered, there are a lot of advantages to cross-platform development, but this approach also comes with its disadvantages. Let's take a few moments to explore some of these. An app built for multiple platforms might mean the exclusion of some platform-specific features that a native app could take advantage of because a common code base must be used. The use of advanced features might negatively impact battery life and other system resources. And integrating with platform-specific and user-specific local settings, preferences, storage, and notifications can be a time-consuming effort. These types of issues can lead to a lower quality user experience on each platform. If you were to avoid a cross-platform approach and develop using each platform's defined native code base, then you could utilize all its features and focus more on UI and UX design. Developing specifically for a particular platform means that you don't reach the user base of other platforms with your app. However, your app may work better on the chosen platform and provide a superior user experience. You can now identify the advantages and disadvantages of cross-platform app development. Great work. Make sure you use this new knowledge to help you improve your development process. To emulate something is to copy or imitate it. For example, you listen to your favorite band and they play a song from another band or artist. You might also be familiar with retro gaming. This is the process of emulating or imitating a classic video game console, allowing you to play it on a modern computer or device. Emulation also exists in software development for developers building web and mobile apps. Here, an emulator is a piece of hardware or software that enables one computer system to imitate another. This gives the host computer the ability to run software or devices designed for the emulated system. By the end of this video, you will know what an emulator is and how they work for mobile app development. Emulation is a fundamental computer principle with a long history. While mobile apps are consumed on mobile devices, developers build these apps by coding on computers. To test the code, developers need a way to emulate mobile operating systems like iOS and Android. Mobile emulators use the existing computer hardware to replicate the environment needed to execute iOS or Android. The emulator provides access to any required system-level capability to replicate the mobile device, including the amount of RAM or working memory, the processor type and speed, the screen size and resolution, and the amount of local file storage available. Emulators save the development team time and money by allowing them to implement different test environments that reliably replicate the end user's devices. Much of the initial testing is carried out on the emulated device, especially for developers building cross-platform apps. While emulators are a powerful solution, they do have some limitations. For example, while you can emulate the iOS environment on a PC, even the best programs cannot emulate some aspects of the native mobile environment. Emulators can also put a bigger strain on resources such as the processor, RAM, battery, and storage. The size of the app will also be bigger, with a larger code footprint overall, making the functioning of the app slightly slower than true native. As a result, it's standard practice for developers to test apps on both the emulated environment and physical devices whenever possible. However, because there are so many different devices on the market, testing on them is not always viable, and emulation is preferred if the app will be deployed to a platform like the App Store or Google Play. Okay, let me introduce you to some emulator examples now. Typically, a cross-platform framework will include an emulator or suggest one to use. Developers can use platform-specific emulators like Android Studio for Android and Xcode for iOS, or even online emulation services like appetize.io. Finally, let's look at an example of an emulator in action. With this particular emulator, the mobile device is replicated to a high level of accuracy and performs with the full functionality of the real-life device. You will learn more about emulators later. In this video, you learned about emulators and how developers can use them to help create mobile applications. They provide a fast and effective way to preview your app during development.
I'm sure you've noticed that when you shop online, websites will often provide you with personalised recommendations, but when your friends log into those same websites, the recommendations will differ. But did you ever wonder how websites adapt to different user profiles? In this video, you will learn the difference between static and dynamic content. You will also be able to differentiate between the role of a web server and an application server. By now, you know that when you open a website, a web server sends the website's content to your browser. The content can be static or dynamic. Static content is files that the server transfers just as they are stored on the web server, such as videos or images. Dynamic content, on the other hand, is generated when the HTTP request is made. For example, the content may be generated based on input from a user, or when you visit a news website, it would be based on the current date. What actually happens is that the web server communicates with another kind of server, called an application server or a backend. The application server generates the dynamic content that the web server sends back to the user's browser. Now you know the difference, let's look at examples of how websites update static and dynamic content. Say, for instance, you want to watch a video on a website. You click on the play button and a request is sent to the web server. The web server responds by sending the file to your browser. Now, how does this compare to dynamic content? Because dynamic content is generated while you use a website, it typically takes longer to generate than it takes to send back static content. For example, when you log into this course, the web server communicates with an application server to check that you are in fact enrolled. The application server confirms your enrollment and specifies what content should show for your profile specifically. Application servers perform more complex processing than web servers. For instance, they have to run application logic, communicate with a database, and check permissions. To improve performance, different application servers have specific purposes. There are application servers for every type of content out there, from music streaming to creating your own blog. You can even create your own application servers, such as building a backend for a web application. But hang on, if dynamic content is slower to generate, isn't that a problem for big websites? Yes, it is. Application servers typically have a limited capacity on how many requests they can process per second. But fortunately, this is where the web server can help out. Web servers use a process called caching instead of generating content dynamically for every request. Caching means the web server keeps a copy of dynamic content. If the content is requested again, the web server can immediately send this cached version instead of passing the request again to the application server. On the first request for dynamic content, the web server checks if the content exists in the cache. If it does not exist, the content is requested from the application server and stored in the cache. The web server then sends back the dynamic content to the browser. On subsequent requests, the web server immediately sends back the content stored in the cache. This reduces the amount of dynamic content that the application server has to generate. Then, after a period of time or with the next user interaction, the web server updates the cache with the latest content. Now you know the difference between static and dynamic content, as well as the difference between web and application servers. With this new information, try to identify whether the content on the websites you visit is static or dynamic. Let's say that you're thinking of building a web app. You probably want a user-friendly, mobile-friendly experience. Then you should consider using single-page applications or SPAs to build a unique, speedy, and engaging experience for your users. You're probably using many SPAs every day. Think of your favorite social network or messaging app, or the map application you use to find local businesses. The great user experience you get is driven by single-page applications. So, what exactly is an SPA? How does it work? How is it different from a traditional website? Let's first explore how a traditional website works. Before the advent of modern JavaScript frameworks, most websites were implemented as multi-page applications. But this makes traditional applications resource-intensive to web servers, because sending entire web pages for every request consumes excessive bandwidth and uses CPU time to generate dynamic pages. If your website is complex, the site browsing experience may appear slow to users. It will be even slower if they have a poor or limited internet connection. To solve this problem, many web developers build their web applications as SPAs. It's called single page, but that doesn't mean your website has only one page of content. What it means is that there is only one HTML page that gets sent from the server to the browser. But that page will update its content as your users interact with your website. A SPA allows the user to interact with the website without the application needing to download entire new web pages. Instead, it rewrites the current web page as the user interacts with it. The result is a browsing experience that feels faster and more responsive to user input. When the user navigates to the web application in the browser, the web server returns the necessary resources to run the application. A SPA has two approaches to serving code and resources. The first is called bundling, and the second approach is known as lazy loading or code splitting. With bundling, when the browser requests the application, the server returns and loads all necessary HTML, CSS, and JavaScript immediately. With lazy loading, the browser requests the application, and the server returns only the minimum HTML, CSS, and JavaScript needed to load the application. Additional resources are downloaded as required, for example, when a user navigates a specific section of the application. Both approaches are valid. The choice depends on the size, complexity, and bandwidth requirements of the application. For instance, with the bundling approach, if your application is complex and has a lot of resources, your bundles will grow quite large and take a long time to download. You could end up with a site that is slower than a traditional web application. Let's explore an example. Imagine you have a site dedicated to reviewing movies. People never know what to watch next, so you decide to install a feature that randomly suggests the movie for a user. You create a web page that has a What to Watch Next button. You want to display a random movie name when the button is clicked. In a traditional website, when the button is clicked, the browser will send a post request to the web server. The web server returns a new web page containing the button and movie name. The web browser then renders the new page. In an SPA, when the button is clicked, the browser will send a post request to the web server. The web server will return a JSON object. The application reads the object and updates by displaying the text of the movie name. That's more efficient because the rest of the page remains as it was, and its content does not need to be sent by the server and rendered by the browser. But what if you need to update the majority of the page to display a different form of content? Well, let's explore that scenario. Suppose you are building a web application that has two pages. One page shows the latest news, and the other page shows the current user's profile page. A navigation bar at the top of the site contains a link to each page. In a traditional website, when the user clicks the profile link, the web browser sends the request to the web server. The web server generates the entire HTML page and sends it back to the web browser. The web browser then renders a new web page. In a single-page application, different pages are broken into templates, also known as views. Each view will have HTML code that can be updated by the application. For instance, the profile page would have a username, a first name, and a last name. The web browser sends the request to the web server, and the web server sends back a file called a JavaScript object notation or JSON object. This contains only the data to be displayed, such as a user's first name and last name, and the SPA will update the HTML. This is much smaller than sending an entire web page. The web browser then updates the web page by inserting the template with items replaced by the values in the JSON object. For your next website, consider whether its complexity suits a traditional multi-page application or would perform better as an SPA. Remember that a single-page application has two methods of delivering resources: delivering all resources immediately or delivering resources dynamically as required. If all resources are delivered when the application is loaded, the single-page application must include the views for every page on initial load. If resources are loaded dynamically, the single-page application requests the views as required and stores views in the browser for subsequent requests. Now you can compare some popular SPA websites to traditional ones and judge the performance difference for yourself. I'm sure you've created something from scratch before. I bet you realised how challenging it can be as opposed to using pre-made components. Think about the effort that goes into building a brand new house versus the convenience of constructing a modular building with pre-made components that you just need to put together. React is focused on working with components, which makes it simple to build functional user interfaces on web and mobile. And since React is one of the most popular JavaScript libraries, it's important that you can explain what its purpose is and describe how its components work together. Available since 2013, React is an open source library with a community of core contributors and companies that maintain it. Developers use React to develop single-page applications, and you can also develop mobile applications with React Native. When you develop an app, you can choose to use React to develop the user interface, but building an application requires more than that. You must also consider the navigation and how the app will request data from a web server. Therefore, React is used in conjunction with other JavaScript libraries during development. But what makes React so useful is that it allows developers to write less code to create functionality. This in turn makes it easier to maintain code in the long term and simplifies testing. Because it is so central to front-end development, there are many tools that you can use with React. These tools can help you understand how React is running your code and how you can improve performance. Now that you have a better idea of what React is, let me tell you more about React's components. The key concept behind React is that it allows you to define components that you can combine to build a web application. A component is basically a small piece of user interface, such as a music player or photo gallery. This component model allows you to do several things, such as developing and testing parts of their application in isolation, and it also allows you to reuse components across multiple sections of the application as well. Let's explore an example. Most web applications have user profiles with pictures. Normally, several parts of the application use a version of this profile picture, such as in the navigation bar beside the user's name. It could also show in a user search result along with several other user pictures. And the user picture might also display in instant message notifications. Instead of programming the logic for every instance of a user profile picture, React allows you to create a user icon component that displays a version of a profile picture every time it is used. You can then reuse this component throughout the application. Can you imagine how it will improve your efficiency? There are, in fact, many open source libraries that provide pre-made components for React projects. For example, if you want to add a video player to your website, there's a React component library for that. Or maybe you want to embed a map. There's a React component library for that too. As the React community grows bigger, it continues to add new features and improvements continuously. Annual React conferences encourage community sharing and introduce upcoming developments in the library. I hope that in the near future, you might be joining the React community as an active member. And as a future React community member, you now know the React library's purpose and how its components work together to make life easier for front-end developers. After all, why build something from scratch if the components are already there to use?
It's probably the coolest thing about React. You learn it once and you can write code almost anywhere. It's one of those ubiquitous technologies that if you're building user-facing products, React is a good bet. Take one and... Oh, I'm having fun now. I'm Benedict Hobart. I'm a front-end engineer at Meta. I think React was created at this time where we had a few other frameworks were sort of at the tipping point when people started taking web development seriously. There was a lot of excitement about writing JavaScript and using React to build apps, and the amount of momentum React created after it was open sourced, and later, once React Native came about, it was definitely at a time where web applications were becoming really complicated, and this UI library was necessary and to make apps actually work, because before then there was nebulous structure for a lot of products. There's an entire org at Meta building React. I'm on this team called React Apps, which is about 100 people, and there's a sister team called React Technologies. And then there's the supporting React Apps team, which sort of builds a lot of frameworks and that sort of thing to use React properly. So yeah, it's grown into a very large group of people supporting the technology at Meta. So there was a lot of imperative code needed in order to articulate how the UI should respond to user events. Where React was unique was that it took our views and made them a pure function of state. So I think that was the fundamental problem that makes React useful. And because it's component-based, it let you define your functions in a way that's easy to reason about and understand what will happen when certain events take place in the system. The sort of applications you'd write as a result of this became easier to reason about versus side effect driven. Things happening anywhere can lead to bugs anywhere. React sort of made it so like this one UI is driven by this input, which simplified things a lot. So there was a big drive to open source technologies in general. And I think the general push around open sourcing technologies is give back altruistically to the developers around the world that, aren't inventing these technologies, and also to get support from them. And I think with the React community that's what makes it so exciting, is that you have so many people in that community caring about how to best build apps, and they all support each other. We've seen, the rise of entire companies built around React. React's impact is massive. So many companies rely on it as a technology. I guess it means job security. I mean, lots of people are hiring for React. Learn JavaScript. Spend some time learning coding. Take it slow, especially if it's your first language. Try and get the foundations. It might take a while to click. It's sort of like a clip. When you're learning programming, things take a while to click. And then when they do it, the pieces fall into place. The jigsaw becomes clear. And you're like, oh, okay, this person isn't a wizard. They're building a house and they know how to use nails and wood, right? So take your time, go easy on yourself.
By now you've learned that you can build components in React to develop user interfaces. But how do React components turn into the elements on the web page that you see? Remember, when your web browser receives an HTML page, it constructs a document object model, or a DOM, to represent it. But updating the DOM is considered expensive because it is very time-intensive for the web browser to do so. Every time the browser DOM is updated, it causes the browser to recompute the page. Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain how React solves the problem by computing its own virtual DOM. Let's start with how React components relate to the website displayed in your browser. A React component has a one-to-one relationship to an HTML element that is displayed on the web page. But how does React keep track of which HTML elements need to be updated? This is where React's virtual DOM comes into play. When React builds out its tree of components, it builds out its own DOM in memory called the virtual DOM. The virtual DOM is a representation of the browser DOM that is kept in memory. React uses this virtual DOM to update the browser DOM only when it needs to. This ensures that your application is fast and responsive to user input. Let me explain how it works. React checks to see if the HTML components in the virtual DOM matches the browser DOM. If a change is required, the browser DOM is updated. If nothing has changed, then no update is performed. This process is called reconciliation. Let's break down what happens when you update a component in React. Firstly, the virtual DOM is updated. Then React compares the virtual DOM to the previous version of the virtual DOM and determines which elements have changed. The changed elements and only those elements are updated in the browser DOM. Changes on the browser DOM cause the displayed web page to change. In this video, you've learned that React constructs and updates a virtual DOM so that the browser will only update certain HTML elements instead of recreating the entire page. Planning an application as a series of components can be tricky at first, but after doing it a few times, it'll become easier. You've already learned about the core internet technologies, and now you know that JavaScript libraries in React allow you to develop user interfaces much faster. Isn't it cool that you can develop user interfaces so quickly? In this video, you will learn how the component hierarchy works in React. Every React application contains at least one component, the root component or app component. Components are added to the app component to build out a tree structure of components that make up the application. Let's explore an example of how an application might be structured as components. Suppose your application is a shopping list of items that need to be picked up from the grocery store. At the root, we have the app component. The app component has two child components, new item bar and shopping list. The new item bar component allows us to add new items to the list. The shopping list component contains a shopping item child component for each item in the shopping list. Even though the item itself might be different, such as chicken or noodles, it is displayed in the same manner as other items. Therefore, you can reuse the shopping item component to display multiple items. When a user ticks off the items, the list will update and remove the corresponding shopping item child component from the shopping list component. Now that you understand the component hierarchy, let's explore how a website can be broken down into components. As an example, I will talk you through a typical blog website. Normally, there is a heading, a menu, and a search bar. You also usually have a featured blog post that displays larger than previous blog posts below it. Now, let's unpack the component hierarchy. At the root of the component hierarchy, you have the app component. This is the entire web page. The app component has two child components, the navbar component for the navigation bar and the page component. The navbar component contains the title of the blog, navigation links for the website, along with a search component. In the page component, we have three components, the main feature component and two instances of a small feature component. The main feature component displays a blog summary about a specific blog post. In the small feature component, there is a blog summary and a thumbnail component to display an image associated with the blog post. Notice that the small feature component is used twice. It is the same piece of code, but for the second small feature, the code uses different properties. And that is exactly the benefit of building a website with React components. You can reuse code for multiple sections. Using a series of components to build an application can be tricky at first, but after you do it a few times, you will appreciate how handy it is. Good luck with planning your component hierarchies in React.
Isn't it great when you have a device or process that can perform more than one task? For example, imagine that you own a grocery store in your hometown. You originally built your own website and your customers can place orders online. You know that these days most of your customers use mobile devices and you want them to have access to your online store no matter what device they use. Often applications are built separately for web and mobile devices such as iOS and Android. But having two different teams maintaining two different code bases for iOS and Android devices would be expensive and inefficient. This is where React Native comes in. React Native can reduce the number of resources required to build mobile applications. Instead of creating two different versions of the same app, you can save time and money by building real native apps for iOS and Android using a common code base. In this video, you will learn about React Native and the benefits of a common code base. First, let me take you on a journey back to 2013, when React Native began its life as a hackathon project. Back then, if you wanted to develop a mobile version based on your app, you needed to wrap it in a component browser on the mobile device using specific third-party tools and software. While this worked, trying to emulate the look and feel of the native operating system still required different components and technologies. In the end, the user experience just wasn't the same as using an app specifically built for the operating system of that mobile device. The term native development refers to creating apps specifically for a single platform. So, this ambitious project aimed to achieve this native mobile development using the same web development features of React.js. The React.js library was gaining massive popularity in the web development world, especially for single-page applications. It allowed developers to create apps with powerful user interfaces that were fast and scalable. Unfortunately, if developers wanted a mobile version of that same app, development tended to be more challenging and needed more effort. At this time, mobile development was considered a more time-consuming process. Engineers wanted to create the React-like ecosystem of fast iterations and a one-team development workflow. There was a need to reduce the complexity associated with mobile development. These resources included multiple teams and technology stacks, which generally resulted in a slow turnaround. If you wanted to create a mobile application, you needed 2 development teams to build it for the 2 main operating systems, iOS and Android. The teams needed 2 different skill sets: development environments, operating systems, programming languages, and user interface elements. To sum it up, it was all just different. With 2 different development processes of the same app, updates also became problematic. If one operating system was updated, it would require an update to the mobile app, which would affect the other app running on a different operating system. As a result, 2 teams of developers were constantly back and forth, making changes for each platform. Using React Native, developers write a single codebase that can be exported to build web, iOS, and Android apps. It allows one team to build one application that will work seamlessly on both platforms using the built-in or platform-specific components and user interface elements. For example, React Native allows developers to use the mobile platform's built-in or native components, such as the camera, while using the same programming language. The team can now work in the same development environment and share the platform components while accessing a shared codebase. If an operating system of a mobile device gets an update, it's not an issue. The app is using the native components that have also just been updated. While this might seem like magic, it's actually just JavaScript. More specifically, a JavaScript framework that combines the best parts of native development with React. React Native developers have a saying: with React Native, one team can maintain 2 platforms and share common technology, React. In this video, you learned about React Native and the benefits of a common code base.
React Native is a framework that can power experiences on a multitude of platforms. You can learn the language, the framework, the tooling once, and you can create an iOS application, an Android application, or a virtual reality application, and even potentially future platforms that aren't around yet. Hi, I'm Eric Hartzog. I'm a software engineer at Meta, based out of Denver. I currently work on React Native, using it to help build applications for the Quest. So one of the biggest misconceptions that I often face is, as a React Native developer, people think that, oh, you're a front-end developer, your job is to change the color blue to the color red, and that's pretty much what you do. Well, there's actually a whole bunch to it, especially in a framework like React Native, where you're essentially compiling a native application for iOS, for Android, for the Meta Quest and VR. There's a lot of pieces that have to fit together, and so the front end just isn't about styling anymore. It's understanding how all the pieces fit together, and that's one of the things that I really enjoy doing, because it's a challenge every day, and there's always new platforms, there's always evolving platforms, and so the learning really never stops. So before React Native came around, if somebody wanted to create an application for iOS and also for Android, they needed to do it twice. A lot of times this meant 2 teams, one for iOS, one for Android. You could find devs who maybe knew both, but they weren't specialized in either, and so it'd be kind of a challenge to really have a polished app working in both. So the need for React Native came out of trying to deploy applications using web technologies onto mobile devices. There's a lot of problems with this, such as performance, touch interactions, camera access, all sorts of small issues which came up. Really what we needed was a way to build true native mobile applications, back in 2012, there wasn't a lot of options for how to do this. So it was kind of a build your own road, figure out how to do it kind of thing. Facebook.com was transitioning to a mobile first focus. So they realized they needed to deploy mobile applications on iOS and Android. So when React Native was first created, it was kind of a brainstorm, and which led to a hackathon. So a hackathon is a block of time where a developer can try out an idea that may not pan out. And that's okay, because sometimes you don't know if something's going to work, and you just need a chunk of time and you say, hey, this is going to take me a day, this is going to take me a week, or this might take me a month, and I want to try this idea. And React Native was one of these products. So it actually didn't start out as a full dedicated team. It was more of an idea that somebody had and that said, hey, Facebook created the React framework, and it's been a great success on the web. Let's see if we can use this to create something for iOS and Android. They created it, they experimented with it, it was working, it was great. And so in the end, Facebook decided to dedicate a full team to React Native and proceed down that path. So fast forward to about 2015, they decided to make the decision to open source React Native. When the launch of React Native was first announced as open source technology, it was really exciting because people across the development world had already signed on to React. React was a great framework for building web applications, and it had a stable developer community that was really behind it. And so when React Native came around, all of a sudden, these developers with this skill set realized they could potentially use React Native and the knowledge they used from React to build an iOS and Android application. So all of a sudden, instead of just being a web developer, without going through too many steps, you can now be an iOS and an Android developer. And there was a lot of excitement about this because previously you had different silos for different platforms. And if you were an iOS developer, you couldn't necessarily go into web or Android. But now you could have one developer switch back and forth between web, iOS, and Android whenever they needed and be able to build an application for that. And that was a big change in how we look at application development. So right now, my work is unique in that I am focused on building React Native applications for the Meta Quest in virtual reality. And if there's any place exciting to be right now, it's in virtual reality. So that's a new platform for which we don't have a lot of guides, a lot of how-tos. And so a lot of it is figuring out as you go. Luckily, we can bring this knowledge that we have from previous experience with React Native. So I've worked in iOS, I've worked in Android, I've worked with React on the web. All that experience, all that tooling, I can bring with me to VR now to help create VR experiences. And it's really exciting to be able to do that, to apply those lessons learned and to create really vibrant, interactive experiences in virtual reality using the tools that we're already familiar with. Now is a really good time to be learning React Native. The market has already proven that React Native is a success on iOS and Android. It's used by major corporations all over. There's a huge developer community around it. React Native is always changing because iOS and Androids are always changing. Our devices are always updating, and so it's not a static, stale platform. It's something there's always something new to learn, and it's always exciting to be in. So to help build confidence starting out with React Native, recognize that there is a vibrant, active community out there, and there's open source discussions and all sorts of ways to find the information that you're looking for to help you build your application. So whether that's looking at GitHub issues, starting your own, going into Discord chats to talk with developers or other people working on their own applications, go engage in discussion, go engage in the community, and be aware of the resources out there for that communication. I wish you luck in learning React Native, and I hope that building your first application is a lot of fun and you're able to get good feedback and experience with the React Native community.